Hello and welcome to BioRules video lessons. Today we are going to be talking about biomes. So biomes are basically global ecosystems that are huge, gigantic and globally in scale. You probably know some of them like tropical rainforest, temperate forests, boreal forests, savanna, deserts and so on. And the biomes, they are mainly determined by environmental conditions, by climate. Okay? An ecosystem is a combination between community and abiotic factors. So what will determine if you have a tropical rainforest, if you have a temperate forest and so on, is going to be mainly the climate, determined by three characteristics. One, solar radiation. Actually, the solar radiation is dependent on where in the planet the location is, and it's going to be influencing the other two as well. So temperature has a very important influence in which biome is going to be developing in which place, and also the precipitation, how much rain, how much snow is going to be in that place. Having said that, let's take a look on the distribution of solar radiation around our planet. So, planet Earth is round, actually it's kind of spherical, and because of that it has a different solar incidence depending on where you are. Actually, the sun sends the same amount of light to anywhere in the planet, but it's going to be hitting the surface of the planet in different angles. If you're around the equator, the area that's going to be hidden is going to be perpendicular to the sun rays. That means that the sun rays around the equator, they are going to be very concentrated. If you move away from the equator, like here in a temperate zone, what we are going to see is that the same amount of sun rays are going to be hitting a much wider area. So you have the same amount of light, wider area, so you have a smaller density of sun rays in that area. To make it even more clear, if you go very far away from the equator, near to the poles, you're going to see that the inclination of Earth is going to be huge, so the area of the same amount of light is going to be hitting a huge, gigantic area, so a much smaller density of sun rays. So this is going to be changing the incidence of solar radiation on the surface of Earth. Just to exemplify here again, around the equator, light is going to be in a much more concentrated over a certain area. And away from the equator, it ends up being less concentrated. So you have less light, so you have less solar radiation. Okay? So, although, because the Earth is inclined, because we have an inclination, there is a variation along the months. Different months suffer different incidents of radiation in a certain place. Overall, if you are close to the equator, you are going to have an average solar radiation that's much bigger than anywhere else. Although in some part of the year you can have a higher solar radiation, even in the North Pole, but on the average you're going to have much more solar radiation around the equator. As a result, the temperature in the equator is also going to be higher. So here you have a classic example. Here you have different biomes. This is tropical rainforest, the rainforest that's common around the equator. Okay, it's not the hottest biome in any season of the year. The grassland and the temperate deciduous forest can be hotter in July in the northern hemisphere, but on the average, around the equator, you're going to have a much higher temperature, much higher average yearly temperature. Okay, so this is going to have an influence on what is the average yearly temperature of a certain biome. So, radiation will also influence productivity. Where you have more radiation, you have a tendency on having a higher productivity. So around the equator here, you have tropical rainforest, high productivity, lots of photosynthesis. Away from the equator, you have lower. But there are other factors that will influence this as well. Okay, so let's take a look on precipitation, because the precipitation can also vary according to the location on the planet that you are. So, precipitation or rain or snow, whatever, depends on several conditions. The first one has to do with temperature, has to do with solar radiation. So I'm illustrating here what happens around the equator. The equator is a very hot place. Sun rays hit the surface, warm up the air, creating a low pressure zone, making the air to go up. You probably know that hot air rises. That's why you have hot air balloons. But when the air rises, it starts cooling down. Now, and then it gets all the way up there into the troposphere, it gets cold. And when it gets cold, it drops because cold air goes down. Hot air up, cold air down. So you're going to have a high pressure zone because the air now is getting down. So this here creates a circulation of air because of the solar radiation hitting the surface. Okay, what that has to do with precipitation. Okay, before we go there, let's try to revise another concept on chemistry. Hot chemicals, like hot air or hot liquids, are capable of have more material dissolved into it than cold air. So hot air will have much more water dissolved into it before it reaches 100% humidity. So both situations here you have 100% humidity, but because this one here is a hot environment, you end up having much more water vapor dissolved in that air than in a cold environment that you're going to have less water vapor dissolved there. So this summarizing, hot air is capable of holding much more water vapor. So it keeps much more water vapor around the air when it's hot than when it's a cold air. And this difference is quite big. Pay attention that this graph here is logarithmic. So this value here at 20 degrees Celsius, now when you double the temperature, you much more than double the amount of air that's going to be capable of dissolving in the air, or the amount of water that will be able to dissolve in the air. So hot air holds lots of water, cold air holds less water. That's why when hot, moist air hits a cold surface, it condensates, because then the air surrounding that surface gets cold and the water escapes because that air, now cold, cannot hold water anymore. So this is what's going to be happening into the water cycle. So hot surface of the ocean or on trees are going to have lots of evaporation. So the water evaporates, gets into the air around hot, moist, and climbs. Hot air goes up. But when it goes up, starts cooling down. And when it starts cooling down, it starts condensating, forming clouds. In the moment that these clouds get very, very, very saturated, especially if it cools down a little bit, boom, you have precipitation, you have rain. So the rain is nothing more than the air that was in the hot air, moist, filled with water. Now this air gets cold and doesn't manage to hold so much water anymore, so it precipitates. So let's put here this in a global scale. If we go around the equator, the hot there is the air there is going to be hot, and because it's hot, it climbs. It climbs hot and moist. But when it starts getting up, it gets colder. It starts not being able to hold so much water, forming the clouds. And after a while, it forms rain, it precipitates. That's why it rains so much around the equator. It's a very rainy place. And what's interesting is that air that went up in the equator, now it's cold and now it's dry because it lost water. This air circulates in a cell and ends up getting down around 30 degrees. In this case here north, but it will get down 30 degrees north, 30 degrees south. This air now is colder and it's dry. That's why around 30 degrees is where you have many of the strongest, biggest deserts in the planet. Then the air moves away from 30 degrees, starts running over the surface, starts getting warmer, and starts getting humidity from the surface as well. This air goes up around 60 degrees latitude, and when it goes up, it gets colder, it forms clouds, and it precipitates. So around 6 degrees latitude, we have again another wet, moist area because we have lots of precipitation. This area that went up now is cold and dry, gets down again at 30 degrees latitude. Hey, so we have here a circulation making wet at around the equator, dry around 30 degrees latitude, wet again around 60 degrees latitude. And we have another circulation here, which the polar circulation is quite weird. We're not going to get into details about that one right now. If we put this in a global perspective, we'll see there, hot getting up, this place is going to be hot and rainy. Then it gets down around 30 degrees latitude, north or south, and here it gets temperate, so it's colder and dry. And then the air circulates back again to go to the equator and to go up, but it also circulates away from the equator, going to 60 degrees and climbing up, going up, warmer and dry, and wet, and now it's becoming to lose water and rain, so this place here ends up getting cold or colder than anywhere else and very rainy as well. So we have these circulations, and of course, as I told before, we have the polar circulation, which is a different one. But this is just to illustrate that different latitudes influence if you're going to have hotter or colder. No, away from the equator gets colder and colder and colder, but also influence if you're going to have a rainy area, dry area, rainy again. So this is going to have a major influence on the temperature and also on the precipitation, how much it rains. This image here is just to show you that we have different areas of temperature and of precipitation around the globe depending on the latitudes. Okay, so just to illustrate, many of the major deserts in the planet are around 30 degrees latitude. Atacama, Namibia Desert, the Australian outback, the Sahara, Middle East, Mojave Desert, around 30 degrees latitude. It makes sense. It's the place where the air comes down and very dry. Okay. Also, this explains why we have around the equator here very moist, very moist biomes, tropical rainforests. Okay, so the equator is a very rainy place, and also you have some of kind of away around 60 degrees latitude. You are going to have very moist places as well. Very good. So if you want to know more details about solar radiation, I suggest this movie. If you want to know more about the circulation cells and how it influences precipitation, I suggest these other movies. It's a short one. It's very cool. Go for it. But I want to show you one more detail that influences precipitation. And this is the circulation of air and water masses. Because of circulation of the planet Earth, the rotation of planet Earth, the circulation of air is kind of weird. Okay? Air masses moving in the direction of the equator tends to move westward, like we have in this diagram here. But air masses moving away from the equator tend to move eastward. This creates a circulation. This circulation that's promoted here is caused by something called the Coriolis effect. If you want to know more about Coriolis, we have it more in a few videos ahead, but just to illustrate that this Coriolis effect makes the water masses in the oceans to circulate counterclockwise in the southern hemisphere and clockwise in the northern hemisphere. And this will be very important in the climate of the coastal zones. If you want to know more about Coriolis effect, this video is very cool, although this video shows quite the opposite. It shows that in the northern hemisphere, Coriolis makes water body circulates counterclockwise, and in the southern hemisphere clockwise. But if you want to know how this Coriolis affects and makes the opposite circulation in the big water mass like oceans, then you have this other video over here. Okay, have fun. It's a beautiful physics phenomenon. I think if you are interested into this, you're going to like. But let's go back here to talk about currents. In the coast of Brazil, you have a current that's coming from the equator in a counterclockwise circulation. If you're receiving water from the equator, this water is going to get there hot and the air is going to be moist. Because of that, the east coast of Brazil is hot and very rainy. It rains a lot. If you know Ubatuba, Caraguatatuba, São Sebastião, all those places, it rains a lot in there. And one big reason is because of the air getting from the equator hot and moist. Then the air goes away, and now it's going to be colder and dry because it's hitting the very south of the Atlantic, getting close to Antarctica, and then it will take dry air to the coast, the west coast of Africa. In the same idea happens in the west coast of the Americas. The air getting from Antarctica gets cold and dry, and because of that, the west coast of Americas is very cold and it's very dry, especially in comparison to the west coast. So here is where you have big deserts. So what will happen here is that in the east coast of the continents is where you're going to be having very clearly some massive tropical rainforests. You have here as well in Florida, and you have here in the Southeast Asia. So tropical rainforests, they're not only in the equator, they are also in the tropics on the east coast of the continents. So there you are, you have many of them over there. And here is the opposite. In the west coast of the continents, we have major deserts. Atacama Desert, one of the driest places in the planet. The houses there don't even have roofs. 30 degrees latitude ends in the west coast of the continent. Namibia Desert, the Skeleton Coast, very, very, very dry place. Around 30 degrees latitude and in the west coast. The outback from Australia, the same. Okay, the Mojave Desert over there, the same idea. So if you want to know more about this, another video here, Coriolis effect, I think it's going to be quite interesting. So we saw that the temperature and the precipitation are major determinants on the climate. We saw examples of tropical rainforests and deserts when we were explaining how latitude and the side of the continent influences the moisture, the precipitation. But now let's take a look on a graph that illustrates this here beautifully and nicely. So here you have a biome, tropical rainforest. It's quite hot temperature and quite moist. So we have there no high precipitation, high moisture is going to be determined for you to have a tropical rainforest. If you have a lower precipitation, a slightly lower temperature, you can have them a temperate deciduous forest. But if you have a much colder and a precipitation ranging quite widely from not so much to almost the same as you have in some tropical rainforests, but colder, then you have a boreal forest, the taiga, the coniferous forest. Down there you have a temperature that is as hot as a tropical rainforest, but much drier. So there you have a savanna. What you have there in the heart of Africa and what you have in the center here of Brazil. And if you have it colder, then you can have a grassland. The grasslands that you have in the south of Brazil, that you have in the prairies in North America. Okay, and of course a wide range of temperatures, but very, very, very dry. You're going to have deserts. The deserts then, they are characterized by having a very low precipitation. You can have very cold and ranging from very dry and not so much dry, the tundra. The lichens in the north of Europe, north of Siberia, north of North America, above the line of the coniferous forest. And of course, you can have the permafrost, the permanent ice, which can have a wide range of precipitation, going from 0 to no more than 100 centimeters per year. But the characteristic on there is that it's a very, very cold place, like Antarctica, the central Greenland, and also the top of mountains. You can have this kind of biomes over here. So it's quite important that you should be able to look at a graph like this and to visualize which biome this is going to be. So even if you don't have this information here on the right, looking at a temperature and precipitation diagram should give you an idea on which biome we are talking about. Okay? One interesting thing that you should have in mind is to know characteristics of some biomes like temperature, rainfall, and the vegetation in there. So for example, deserts, they can be very hot during the day, very cold during the night. The main characteristic, they have a very low precipitation, and they have xerophytes. Xerophytes are succulent plants like cactus that are specialized in conserving water. Another example of a biome that would be interesting for you to know is a tropical rainforest. Where you have, it's hot, all year round, and you have very, very high precipitation. And the vegetation, the characteristics for you to have tall trees, lots of undergrowth, epiphytes, plants that grows on the top of other plants like bromeliads and orchids, and you have a very large diversity of species. And another biome that's important for you to know is the coniferous forest or taiga. It's usually very cold, not absolutely cold, it's not below zero, but it can be cold, but on the yearly average, it gets from around 0 to 15 degrees Celsius. You have a small amount of precipitation because there's not much water evaporating in there. And the typical vegetation is coniferous forests and very little variation in the number of species. So knowing some characteristics of some biomes can be very helpful. And now take a time to answer some questions in our quiz. I hope you have enjoyed the lesson. I see you in the next one.